You ready to take your Android development skills to the next level? Then you're in the right place. In this tutorial series, we are going to show you step by step how to build a powerful and efficient shopping list app using the latest tools and techniques in Android development. We'll be using Jetpack Compose and Room database to create a beautiful UI, store and retrieve data and connect it all together. This is not your average tutorial. We're going to dive deep into the code and give you an in-depth understanding of how everything works. So whether you're a beginner or an experienced developer, this tutorial is for you. So fasten your seatbelt and let's get started. Okay, so now we want to start to write our code. So the first thing here, we want to create a new package. So you can navigate here to Kotlin new and select here package. And we want to create a new package that is called data. So this one is going to help us to organize our codes and files in a place where we're going to get our data. So we can create another package, and we want to create this package to be a local database, or we can just call this room so that we can easily understand that we have a package where we have our data rising from room databases. Okay, so the next thing here, we want to create our models. So we can just easily select here new and create a new package and call this model. And basically, let's create here a new Kotlin class or file, and we want to call this model. Okay, so now we want to create our tables where we're going to store our data. So the first case here, we want to create a data class that is going to represent the shopping list. So for example, here we can easily call this data class, and basically we don't want to call this models. So we want to call this, for example, shopping list. And basically here we want to provide the variables or properties which we want them. So for example, here we want to be this ID, and we can just provide this to be an int. So the first case, we have to annotate this class with @entity so that we can tell room, hey, this is just going to be a table inside our database. So just create the implementation for it. So we can just annotate this with @entity. And for example, here we can provide the table name. So let's call this table name. And basically we can just rename to whatever we want. So for our case, we're just going to call this shopping list. Okay, so we want also to make this to be primary key. So a primary key is just something that is going to identify every item inside our table. So we have rows and columns. So every row has a unique ID that is going to represent this record inside this table so that we can easily access it. And we have to tell room database to store this to be as a primary key. And for our case, our ID is going to be our primary key. So we're going to have a lot of data classes. So we want to rename this ID to match our shopping list, for example. So we can use @column_info to tell room database to rename this variable when it's going to store it inside our database. So we can just call this column_info. And basically we want to rename this, so we can provide here the name. Then, for example, we can just call this list ID. And basically it's going to store this as an ID. Okay, so another thing which we want to store here is a name. So we can just call this name of that particular item. Let's add here a comma first. This is just going to be of type string. Okay, so before we start to write the other model classes, we have first to understand the relational database design, because SQLite is just a relational database design, and we are going to use this inside our application. So let's jump here and see what is a relational database design. Now let's speak about relational database. So a relational database design is the method of organizing data in a database using tables and relationships between them. So the main idea behind relational database is that the data is stored in separate tables, and those tables are linked together using relationships, which allows the data to be accessed and manipulated in a structured and efficient way. So we can have data in different tables, but we can easily join them and use them when we want to organize our data. So in a relational database, data is organized into tables, also known as relations. So each table has a set of columns and rows, and each row represents a single record in the table. So for example, here we have the ID, which is denoted as the primary key. So the primary key is just a unique identifier of each record which we insert. So every row is just like a new record inside our database, and this ID is going to represent that this is just going to be a unique identifier of that particular record. So there are three main types of relationships that can be established between tables: one-to-one, one-to-many, and many-to-many. Now let's look at each particular one. So we have a one-to-one relation. So a one-to-one relationship is where one record in one table corresponds to one and only one record in another table. So for example, here we have two tables. So we have a customer and the address, and we want that only a single customer can have the same address, not two customers having the same addresses. So how can we do this? Basically, we have to introduce a new item inside our customer table, which is just the address ID, which is going to be stored inside here, and this is just a foreign key. So a foreign key is just a column or a set of columns that are going to uniquely identify an item in another table. So for example, this is going to directly point to the primary key of this address here. And basically, we are going to store it inside our customer table so that when we want to get this data, we can easily just fetch the primary key, and then we can join these tables and use them. So this is just called one-to-one relation. And also we have a one-to-many. So a one-to-many is a relationship where one record in one table corresponds to many records in another table. So for example, here we have the items and the shopping list. So here, for example, the shopping list table is going to have a single item that corresponds to many items that are going to be there. So for example, we have a shopping list category of, for example, fruits. So here we can have bananas, we can have, for example, mangoes and other things that correspond to the same category, but there are just many. So here we have one category and here we have many items. So this is just one-to-many. And basically, for this case, we have also to store the shopping list ID, which is just the foreign key, and we can easily just map this. So whenever we find this ID here, then we can just join these two tables and have the data inside our application. And also we have the last one, which is just many-to-many. So a many-to-many relationship is where many records in one table correspond to many records in another table. So this type of relationship is usually resolved by creating a joint table with the foreign keys of both tables. So when you look closely here, you can see we have a shopping list and also a customer and another table that is just called the customer shopping list join. And basically here we have two primary keys from each table. And basically here we have a one-to-many and here a one-to-many. So basically this is just going to point to one here and one to here. So whenever we want to create this many-to-many, it's just, for example, we have a lot of customers having different types of shopping list. And basically here we can easily join these two tables. Okay, now let's finish to create other tables. So the second table which we want to create here is the items. So we can just easily create here at entity. And we can just call this to be table name. And rename this to be items. Now let's create here our data class. And we can just call this item. And now here we want to create our ID. So we can just easily create here column info and rename the name here to use as the item ID. And we want to make this to be a primary key for this item. And basically now we want to create our ID. And just call here ID to be of type int. And we want to make this primary key to be auto-generating whenever we insert a new record. So how can we do this? Basically, we can just tell room, hey, auto-generate this particular item. And basically here we can just make this to be 0 so that whenever we create the item class, we do not have to pass this ID here. So we have to provide this default implementation. Also, we can create other variables. So for example, item name. This is just going to be of type string. Also, we want to get the quantity. Okay, so now we want to join between these two tables. And earlier we said that we can easily do this by providing the primary key inside, for example, this table here. We want to join between this item table and the shopping list table. So how can we do this? Basically, we can use the primary key of this item inside here. So let's save here our list ID. So we can create a variable and call this list ID. And basically this is just going to be the foreign key. And this is going to be of type int. Also, we want to create the link between the items and the stores which we are going to purchase them. So for this case, we can create another foreign key. So for example, this is just going to be the store ID foreign key. So this is just the foreign key of the table which we have not created, and we are going to create in just a moment. So this is just going to be of type int. And also we want to save the date. And also we want to store if this is going to be checked or not. So we can just call this is checked. And basically this is just going to be of type Boolean. So now let's create the store table. Now let's create a new data class here. And we can just call this store table. Okay, we have to annotate this with @entity. We can just rename this to stores. Okay, now let's provide here the variables. So we want to provide the ID, and also we want this to be auto-generated. So we can just provide here, for example, @column info. And also we can just provide this to be the primary key, and we want to set the auto-generate to true. Okay, also we want to join between the store and the list table. So we can easily introduce here the list ID foreign key. This is just going to be of type int. So whenever we store this table here, we're going also to store the reference of this primary key here. So whenever we want to get the shopping list and the stores, we can easily just use the join between these two variables. Now we have finished to create our data classes and entities. So now let's create our data access objects, which are just methods which are going to help us to interact with our database. So we can perform the CRUD operations by using DAOs. So now let's jump inside here, our room package, and now let's create a new plotting class of file. And basically we want to create a file and call this DAO. Now let's first create the items DAO. So this is just an interface, and we can just call this item DAO. And basically we have to annotate this with @DAO to tell room, hey, this is just going to be a DAO implementation. So now when we finish to create that, now we can just start to create our methods inside here. Okay, so when we want to perform the CRUD operation like inserting, deleting, and other things, so we have to perform them here. We can create a suspend function, and we want to call this insert. And basically this is going to help us to insert our item. So we can just call this item. Okay, so we have to annotate this with @insert to tell room, hey, create the implementation for inserting the data. So when we call this @insert, and we want to provide the on-conflict strategy. So for example, when we insert an item that has the same ID, then we have to, for example, replace or ignore. So for our case here, we want to replace whenever we provide this. So we can just use the on-conflict strategy and call .replace. So for our case here, whenever the items have the same ID, they are going to be replaced with a new one. Okay, so we have to create another one, which is just @update. And here we can just pass in the on-conflict strategy as the same. And create a suspend function, and we want to call this update. And easily we can just pass in the items, and then it's going to update the items. Okay, now we have to add another annotation, which is just @delete. And basically we have to provide a suspend function here and call this delete. And basically we can just pass in here the items, and the items is going to be deleted. So as you can see here, we are using suspend functions throughout these methods, because these methods are going to take sometimes a lot of times. So we don't want to clog the main UI thread. So for this case, we have to use another thread in order to execute these methods. That's why we are using here, for example, suspend functions whenever we want to delete these. Okay, so the next way here is just to get the items. So we can use @query and provide a query statement whenever we want, for example, to get an item. So basically here we can just call here, for example, @query. And inside here now we want to provide the query which we want to get. So for example, here we want to select. And we're going to pass in here the asterisks, meaning we want to select everything from the item table. We can just call from items. And basically it's going to get everything from the item tables. Now let's pass in here a function, and we want to call this get all items. And this one is going to return a flow. So we are going to use here a flow, so you can use live data and other things. So for a case here, we want to use a flow, and this is just going to be a list of items. So we want to get every record inside our items. So as you can see here, we are not using a suspend function because we are using here a flow, and flow is just a called item. So basically here, whenever we want to use this, we have to use a coroutine scope in order to consume this data. And that's why we are not using here a suspend function. Okay, now let's add another item here to get a specific item. So let's add query. And here basically now we have to provide the query. So for example, here we want to select everything from the items. And basically now we want to filter here. So we want to filter with where. So we want to use this item ID is going to be equal to the ID which is going to be provided. So now let's create here the item ID. Okay, now let's create here our function, and we want to get the item. And basically here we have to pass in the item ID whenever we want to access this. This is just going to be of type int. And this is just going to return a flow, and it's just going to return a single item. So as you can see here, we are just filtering our database by matching the IDs, which is going to be provided here. So for example, whenever we click a single item here and we want to open it, we have to pass in the ID and tell Rook database to filter this data when they match the IDs. So this is just one way of creating our DAO. Now let's create another DAO for another item. Okay, now let's create another interface, and we're just going to call this store DAO. And this is just going to be similar to the DAO which we have written there for the items. So let's just call this @DAO. And basically we want to provide the methods which are just similar to this one. So we can just easily copy this and paste it inside here. So instead of items here, we want to insert a store. And here, instead of updating an item, so we have to pass in a store. And here, for example, on getting all items, we can just easily change this to get all stores. And here we want to select the stores table. And this is just going to return here store. Okay, and here we want to get, for example, a specific store. We can just easily call this get store. Basically, here we can pass in the store ID. And here we want to select from the store table. And we want to change these variables here to be the store ID is going to be equal to the store ID, which is provided here. So as you can see, when you want to access this, you have to pass in these two columns here. And for case, the return type here is going to be store. Okay, so these two DAOs are just similar. So we're going to write here a shopping list DAO, which is just much more complicated. So now let's write it. Okay, now let's create here our new interface, and we can just call this list DAO. It's just going to be the DAO for our shopping list. And we can just easily annotate this with @DAO. Okay, now we can just easily create our methods. So for example, here the suspend function, and we want to insert the shopping list. So basically here we are going to pass in the shopping list as normal. And here we want to annotate this with @insert. And provide here the onConflict strategy, and we want to replace this. So we can just call this onConflict strategy and replace. And basically it's going to replace. So this is just similar to those which we have written. Okay, now let's create here our function to get the items with the stores and list. So we're going to join between multiple tables. So we can just create here a new function and we call this get items. And basically this is just going to return us our stores. Okay, so we have to write here at query and provide our query. So because this query is going to be long, so I'm going to using this string template here so that we do not have problems when we are writing and for visibility purposes. Okay, now we want to call here our select as normal. So we want to select everything from the items table. Okay, so we are going to use here as keyword so that we can rename the table name so that we can easily reference this when we are writing inside our query. We can use these items as I, and we want to provide the inner join keyword. And this is going to tell, hey, we want to join between the items and this particular table. So we want to again join between the items and the shopping list table. And we can just rename this as S. And now we want to provide the condition to join between these two tables. So we can just provide on. So the on keyword here is going to tell, hey, we want to provide the condition to join between these two tables. And as you know, inside the items table, we saved the items and the shopping list ID. So we can use here, for example, the list ID. And this list ID must be matching with the ID inside our shopping list. So we can just use s.listID. So basically here now we are going to compare between these two. If they are equal, then we can just return that item. And also we want to provide another inner join. And we want to join this together with another table. So we can provide here inner joins and we want to join the store table. And we can just rename this as ST so that we can easily reference this inside our code. And now we can use this. We can provide the on keyword so that we want to filter this again. So we can just use I.storeID, and this is just the foreign key of the ID which we have. And then we want to match this with the store's ID. So we can just use st.storeID. So as you have seen here, now we have performed our query. So we want to select everything from the items table, and we use this as to rename these items name so that we can easily reference this inside our code. And we use this inner join to tell that we want to combine between the items and the shopping list table. And as you can see here, we use this on keyword in order to provide a condition to join between these two tables. And for our case here, we are using the list ID foreign key and also the list ID, which is just going to be arising from the shopping list table. And basically when these are going to be true, then these items are going to be joined. And also we perform another inner join again to join the store table. And for this case, we provide the condition that the foreign key that is stored inside the items table must match with the store ID. And for this case, we are going to return our item. So now here we have written our query. Now we want to return all of these items. So as you can see here, we are joining between three tables. And then this is going to return three entities: the items, the shopping list, and also the stores. So we don't have a single data class that is going to manage to hold all of this data. So we have to create a separate data class that is going to hold this data, and we can easily use it inside our UI when we want to display our data. So for this case, we can just jump below here and call our data class, and we want to call this items. And now we want to insert these two items. So for example, here we want to call this item. And also here we want to pass in the shopping list. And also we want to pass in the store. Okay, so all of these items are just embedded, and we have to tell the room that these items are going to be embedded. And the embedded item is just when we provide or we use a join query, because we're joining between three entities. And for this case, we can use just an annotation here and call this at embedded. Okay, so as you can see here, we are just returning all of these items in one go. So for this case, we can just provide here our flow. a list with items and store. So whenever we use this type of join query, then we can just use these items with this store list and retrieve it and use it inside our UI. Now let's provide another method that is going to help us to filter this, for example, according to the list. So for example, when we provide here an ID and we want to filter them according to certain categories, for example, the shopping list, so you can just easily press Ctrl+C and copy this and paste in here Ctrl+V and paste it here. And now we want to call this filtered. So we want to filter this by list ID, and here basically we can just easily add another condition here, which is just by using a where clause. So for example here where, and then we want to check between the store and if this is just going to be equal to the list ID which we have, and here basically we have to provide the ID which we want to filter with. So we can just pass in here the list ID. So basically here we're going to pass in the list ID so that we can easily filter our data according to this list ID. So we can just pass in here the list ID. So we have added here a where clause which is going to filter this according to the stores according to the list ID. And also we can just add another method which is just going to get us a single item with just which is filtered according to the item's ID. So now we can just copy here, Ctrl+C. And paste it here. Now we want to call this, we want to get the item, and now it's not the items. So we're going to return a single item with a store and list filtered by the ID. And now we want to pass in here the item ID. And basically instead of using here the street, we can just use the item and pass in here the item ID, which is filtered with the item ID which we have passed here. So you're going to see this when we use inside our UI. So here we are just filtering, we want to get a single item. So instead of a list, we can just change this here. And we want to return the items with store and list. So here we want an item filtered by the item ID. And here we want to filter this according to the list ID. And for example, here we have used this store. So here we have to use the S, which is just for shopping list here, and not the ST, which is just for store. We can just use this S.list ID, and instead of filtering this with using the store. So we want to filter this according to this store ID, which is just the ID which we are going to be providing here. Now we have finished to create here our methods and the DAOs. We can easily now create our database class, which is going to help us to connect between the database and provide us with the access to the DAOs. So now let's create here a new class, and we can easily call this shopping list database. Okay, so this must be an abstract class and must inherit from the room database. So we can just easily call this room database. And we have to annotate this with @database. And now inside here, we have to provide the entities. So this is going to provide us with the connection to the database. So we provide here the entities which we have. And this is just an array. And here, for example, we have our first, which is just shopping list. So we provide all of the entities which we have created. And the last one, which is just the store. Okay, so the first case we have finished. Now we have to provide the version. So this version here is really important. For example, when we want to migrate our database to another version, then we can easily bump up this number. So for our case here, it's just the first version. And then here we have the export schema. And for our case here, we are just going to pass in this to be false. So we are going to see these when we write the migrations. So for now, we are just going to leave this as false here. Okay, so now we want to provide the access to the DAOs, because this method is going to manage the connection and creating the database. So we have to get the method so that we can easily access our database. So for our case here, we can create an abstract function, which is just, for example, the list DAO. So we want to be able to access our list DAO. Now let's first create here a little room. And this is just going to be of type list DAO. And it's going to return our store DAO. Okay, so we have said that this database class is responsible in creating the connection to the database. So we have to be able to create the database from this class. So how can we do this? And creating a database is just, we have to manage the threads, and also we have to get a single instance throughout our application. So, and an abstract class, we cannot instantiate this class here because this is just an abstract class. So for this case, we can easily create a companion object, because this companion object here is going to help us to create the instance of this class without instantiating this class. So for this case here, for example, we want now to create our instance. And the first case here, because this is going to be accessed in different threads, we have to manage the threads. And basically we can use @volatile. And this volatile here is going to tell, hey, you have to manage this in a thread safe manner. And we're going to do this. Now let's create here an instance, var, and call this instance. And basically this instance is going to return a shopping list database. And basically this is going to be nullable for the first time, because this, whenever we instantiate for the first time, we want to make this to be null so that we can easily instantiate. Now let's create a method that is going to get the database. So let's create here a fun, and we want to call this get database, and provide here a context which is going to be used to instantiate the database. And this is going to be of type context. And now this is going to return the shopping list database. Okay, so we're going to return the instance, but this instance is going to be nullable for the first time. So we have to use this Elvis operator here. So if this is going to be null, then we have to create a new database. And for this case, we can just use a synchronized, and this basically is going to lock. Only a single thread is going to be able to do this. So for example, if we have multiple threads that are running in parallel and call this get database, then whenever we provide this lock here, it's going to lock this, and only one instance is going to be able to access this. And for that case, now let's create our new instance. So we can just call this instance with the small letters. And now we can use our room in order to create our database. And now we can call database builder. And now provide the class name, which is just the shopping list database. And here basically we can just provide the name. So for example, here we can just call this shopping database. And basically here we can just call .build, and this is just going to be building this. And now we want to instantiate this instance here to a new variable, because we have already created an instance here. So we can just call this instance equals to this instance. And basically here we have created our instance, and we can just call return instance. Okay, so the second time we call this get database here, because this instance is no longer going to be null, then this instance which we have created here for the first time is going to be returned. So we will not call this code, because this is not going to be nullable. So this is how we create the database in a thread safe manner, and we have only a single instance throughout our application until when it's going to be killed, and create a new database when we relaunch our application. Okay, so now we have finished to create here our database. We can just easily call this build here or make project, so that we can see if we have any errors and fix them. Now let's just press this and make the room database to generate those implementation of everything which we have written here. And the error is just field has a non-unique column name. As you can see here, we have a column name that is called list ID fk throughout our DAOs. So let's just come here inside our models. As you can see here, we have this list ID foreign key, and also this is just called the list ID foreign key. So we can just easily change this list ID foreign key. So we can just create here Shift F6 so that we can just change this, and we can just call this list ID so that we can just differentiate them. Now we can just easily refactor this, and it's going to refactor everything. So here, instead of list ID foreign key, we're just going to pass in as a list ID. Okay, now let's rebuild again and see if we have any problem. Okay, so this is just the great thing about Room database, because it provides compile time verification. So as you can see here now, Room is complaining again that it cannot figure out how to save this field into database. So you can see here it's providing us with the suggestion you can consider adding a type converter for it. So we're going to see this in the next video, how to add type converters and save custom types which are not supported inside our database. So as you can see here, we are saving a data type that is called date, and inside SQLite you cannot save a type that is called date here. So for this case, we have to provide type converters. So we are going to do this in the next video. So for this video, let's leave it here. So if you find any value out of this video, please don't forget to provide a like and subscribe for more videos. So see you in the next video. Bye bye for now.